All right, so we're diving into some really interesting papers today on generating synthetic limit order book data. Basically, creating like artificial but, realistic snapshots of all those buy and sell orders, that whole dance that drives market prices, right?
Yeah, exactly.
And we've got these two papers, both from 2024, that are tackling this in, I think, some pretty unique ways.
Yeah.
But before we get all, into the AI weeds and the algorithms and stuff, can we maybe just like step back for a sec?
Sure.
Like, what is a limit order book? Just a quick refresher for anyone listening who maybe, needs a little bit of context.
Yeah. So think of a limit order book or LOB, like a live auction, but it's for like a stock or, some other financial asset.
Okay.
And instead of like yelling out bids, buyers and sellers are submitting their orders electronically
Right.
with very specific prices they're willing to trade at. So these are their limit orders.
Gotcha.
And the Let Me Be organizes all these orders with the highest buy orders, which we call bids, at the top, and the lowest sell orders, the asks, at the bottom.
Okay, so it's like a constantly updating ranking then of,
Yeah.
Who wants to buy and who wants to sell at what price.
Exactly, yeah. And the difference between like the best bid and the best ask, that's what we call the spread. And then you have market depth, which is like how many orders are sort of waiting in the wings at different price levels.
Okay.
So a deep market means there's a lot of liquidity, there are a lot of buyers and sellers ready to go.
Yeah.
A shallow market can be a bit more volatile. Prices might jump around a little more easily.
Got it. So the LOB is like, I don't know, a real-time X-ray of that supply and demand for whatever that asset is.
Yeah, that's a good way to put it.
Now, you mentioned that we've got two papers here trying to, like, generate this synthetic LOB data, right? Why even bother? Don't we already have tons of, like, real historical data from the markets?
We do, but using that historical data to, like, test trading algorithms or, explore market dynamics, it has its limits. Imagine you're developing, let's say, a high-frequency trading strategy. You can't just test it on past data and expect it'll be accurate in the live market,
Right, yeah.
The market reacts to what you do, to every order you place. Historical data can't capture that interplay.
It's almost like, I don't know, trying to learn to drive by watching old race car footage.
Exactly.
You got to actually get behind the wheel, right?
Yes.
Feel how the car responds.
Feel it, yeah. Plus, what if you want to play out scenarios that haven't even happened, like a sudden crash or, volatility going crazy?
Right.
Synthetic data gives you that power to experiment with those what-if situations, and you're not risking real money.
That makes sense.
You can really stress test your strategies or even train AI models on a wider range of, market conditions.
So synthetic data is like opening up a whole lab for us to play in, basically.
Yeah, kind of.
Now, one of the papers you sent, 2024 Neural Stochastic Agent-Based Limit Order Book Simulation with Neural Point Process and Diffusion Probabilistic Model.pdf, it gets into this thing called a neural stochastic background trader, which sounds kind of intense. Can you unpack that a bit? What makes that approach special?
No, it's interesting because it tries to bring together like two classic approaches we've used for LOB simulation. You've got your agent-based models, where you've got these individual virtual traders, with specific rules.
Yeah.
And then stochastic models, which are using math formulas to kind of capture the market dynamics. This neural stochastic background trader, or BT, it's essentially an AI agent that learns from real LOB data.
Yeah.
So instead of being hard-coded with rules, it's trained to predict what happens next in that LOB, and even more so, how it's going to happen.
So it's not just like, oh, there might be a buy order.
No.
It's trying to figure out the price, the size, the whole shebang.
Exactly, to make it way more realistic than just random orders popping up. Yeah.
Way more nuanced.
And it uses two main neural networks to do this. Think of the first one like, I don't know, a clock. It's called an SDP-NHP. It's all about the timing, predicting when events are going to happen, like new orders, cancellations, trades, all based on the current state of the LOB.
Gotcha. So it's learning like the rhythm of the market, when things are going to get busy or slow down.
Yeah, that's a good way to think about it.
And then the second network.
That's more like a sculptor. I'd say it's a DDPM, and it handles the details of those events. So it learns the distribution of, let's say, order, prices, and volumes, but it's based on the market conditions at that moment. So if the spread is wide, it might predict more aggressive orders, trying to close that gap, right?
Makes sense.
But a tight spread, maybe you get more passive orders, folks just waiting for a better price.
So it's not just predicting that something happens, but the specifics of how it'll happen.
Yeah.
That's where the diffusion models come in, right?
Right.
Because I've heard about those mostly for like image stuff.
Yeah.
I'm curious how they apply to, money world.
They are fascinating, this whole generative AI thing. And you're right, they've been big in images.
Yeah?
The way they work is you take some data, could be an image, and you gradually add noise to it until it's just pure randomness.
So like taking a clear picture and turning it into static.
Exactly. Then, here's the cool part. The model learns to reverse that whole process. Starts with noise and slowly removes it till it gets back to that original data.
Oh, wow.
And once it can do that, it can generate new data that's similar to what it was trained on.
So in our LOB case, the DDPM's learning to make those order prices and volumes, but ones that make sense given, the spread, how many buyers and sellers are out there.
Right.
It's almost like it's learning the grammar of order flow, if that makes sense.
Yeah, I like that, the grammar, how prices and volumes tend to move. Pretty cool stuff.
It is pretty cool.
Yeah.
But I'm guessing even with all this fancy AI, there's still, some potential pitfalls we got to think about.
Oh, absolutely. Even the best AI trader can get tripped up.
Yeah. What are some of those things, especially when we're trying to be accurate for both, like liquid markets and illiquid ones, which are way harder?
Yeah, so one of the big challenges they point out in this paper is it all comes down to the training data. This study used a very liquid stock, meaning there were lots of trades, small price changes between levels.
Yeah.
Yeah, so one of the big challenges they point out in this paper is it all comes down to the training data. This study used a very liquid stock, meaning there were lots of trades, small price changes between levels. But what happens when you take this model and apply it to like an illiquid market, where trading is sparse and prices can jump around like crazy? That's the big question.
Right. Yeah. It's only as good as what it's learned from, like training a self-driving car in the suburbs and then throwing it into rush hour in New York.
Exactly. And this is especially important when we're talking about those top 5 bids and asks in LOB, right? Especially in illiquid markets, those levels could be way wider, harder to predict.
Yeah. Makes sense.
Another thing they bring up is capturing those really complex dependencies between different market variables. Like even with this DDPM, they found it tough to model how market orders, the ones that just want to execute right away, how they react to imbalances in the order book. Does that make sense?
Yeah. So even though it's learning from real data, it might still miss some of those nuances, how different orders kind of play off each other.
Right.
And especially in those unpredictable illiquid markets.
Precisely. And that brings us to, I think, another limitation here. Both the models in this paper, the clock and the sculptor we talked about, they're only looking at the current state of the LOB. They're not considering any past price history.
So it's like a snapshot in time, not the whole movie, right?
Right.
But isn't that past data kind of important for like momentum, price reversion, all that?
Absolutely. Like if a stock's been climbing steadily, that past trend could totally influence how traders are going to place their orders. This model wouldn't catch that.
Right.
And this is where things get extra tricky when you're trying to simulate those 5 bid and ask levels accurately.
Yeah.
In illiquid markets where even a single order can have a big impact, that historical context could be super crucial.
So this neural background trader, as cool as it is, still has some room to grow, it sounds like, especially for those illiquid markets and factoring in all that past price data. Now, you mentioned a second paper that might give us some more insight into these diffusion models. Does that one address any of these challenges directly?
So the second one, 2024 Dynamical Regimes of Diffusion Models.pdf. It's not about LOBs specifically, but it goes deep into how these diffusion models behave during training.
Oh.
And it highlights these dynamical regimes, which are basically phases that the model goes through as it learns.
Dynamical regimes. Sounds kind of technical. Can you break that down a bit?
Think of it like stages of learning, right? Early on, the model might focus on just the broad statistical properties of the data, kind of like learning the basic rules of the game.
Gotcha.
But as it trains more and more, it enters a different regime where it starts picking up those subtler time-dependent relationships, the more advanced strategies, you could say.
So for LOBs, understanding those phases could be key to making sure the AI is getting not just the overall patterns, but those cause and effect things that really move prices over time.
Yeah.
Especially for accurately generating those 5 bid and ask levels. Right?
Exactly. That's where this second paper's insights could be really valuable. If we get these regimes, we might be able to fine-tune the training to make sure it's capturing both the big picture market stuff and those tiny details that are so important for a realistic simulation, especially in those tough, illiquid markets.
So even though this second paper isn't giving us, like, a direct solution for LOBs. It's more like a guidebook for training these diffusion models the right way, potentially getting around some of the issues we talked about earlier.
Yeah, that's a good way to put it.
It's not just about throwing more data at the problem. It's understanding how these AI tools work deep down and training them so they get the real complexity of these markets right.
Precisely. And this is particularly relevant when you think about our goal here, generating realistic LOB data for both liquid and illiquid markets. We need models that can handle all these different structures, trading patterns, levels of liquidity.
Now, you mentioned before that one of the biggest hurdles with illiquid markets is simply the lack of data. Do you think these diffusion models might actually help us overcome that? Could they be used to sort of fill in the gaps where we don't have much real-world info?
That's a really interesting question, and it's something researchers are definitely looking into right now. That's a really interesting question, and it's something researchers are definitely looking into right now. One idea is to kind of leverage that generative power of diffusion models, right? Remember we were talking about how they can create new data that looks like the data they were trained on.
Yeah.
So what if we could train a diffusion model on data from a liquid market and then use it to, generate synthetic data for a similar asset, but one that's illiquid? Oh, interesting. So it's like using what we know from the well-lit, busy market to shed some light on those darker, quieter corners of finance.
Yeah, I like that analogy. But of course, the big question is, wouldn't that risk, introducing biases, inaccuracies? I mean, even similar assets can behave pretty differently, especially when it comes to liquidity.
Right, right. It's not a perfect one-to-one.
Exactly. So we need to be careful there. The key would be to incorporate some extra information that captures those unique characteristics of that illiquid market.
Like what kind of information?
Well, it could be things like order book depth, trading volume, maybe even new sentiment specific to that asset.
So it's about giving the AI the right context, the right clues to work with, not just spitting out random numbers.
Exactly. And this actually ties back to what we were talking about before, understanding those dynamical regimes. If we can train the model in a way that captures both those general market patterns and the specific features of the illiquid asset, we might be able to generate some pretty accurate, reliable synthetic data. So it sounds like diffusion models could be really powerful for this whole LOB data generation thing, even for those tricky illiquid markets. But we got to be smart about how we train them, what info we feed them. It's not just magic, right?
Definitely not. It's an exciting area, though, for sure.
It is. Now, we've been focusing a lot on the technical side of things, but I'm also curious about the bigger picture. What could this mean, having all this high-quality synthetic LOB data? How might it change the way we trade, manage risk, even regulate markets?
Oh, the potential applications are huge. For traders, it's like having this hyper-realistic sim to test out new algorithms, fine-tune the ones they have.
Yeah.
They could see how their strategies would do under all sorts of market conditions, even those crazy rare events that we might not have enough historical data for.
So it's not just about making money, it's about understanding the risks too.
Absolutely. Like, how would your strategy hold up in a flash crash or a period of insane volatility?
Yeah, that makes sense.
And this kind of sim could be a game changer for risk managers too. They could use it to stress test their portfolios, see how different assets might behave in all these different scenarios.
It's almost like a crystal ball, not to see the future exactly, but to get a better sense of what could happen.
Yeah, that's a great way to put it. And it's not just them either. Regulators could benefit too, right?
Right.
They could use these simulations to see how new regulations might actually play out, how they might change market dynamics.
So it could help make the whole financial system more stable, more resilient.
Exactly, yeah. But it's not just about mitigating risks. It's about unlocking new opportunities for innovation too, right?
Right. Yeah. Like what?
Well, for researchers, having access to this much synthetic LOB data, it opens up a whole new world. They could study market microstructure in way more detail, see the impact of different trading strategies, maybe even come up with completely new models of how markets work.
Is it giving them a much more powerful microscope?
Exactly. And like we were saying before, being able to generate this data for illiquid markets could be especially valuable. It could help us understand those, less explored areas of finance, maybe even attract more investment there.
So it's not just about making the existing markets better. It's about opening up whole new ones. It feels like this tech could really change things in a big way.
I think so. But as with any powerful technology, there are always potential downsides, things we need to think about.
Like what?
Well, misuse, for one. What if someone uses these tools to create misleading or just plain fake market data?
Oh, yeah, that's a good point.
So safeguards are important, making sure these things are being used ethically,
Now,
responsibly.
any tool, right, can be used for good or bad.
Exactly. And we also got to remember the limitations. Synthetic data is never going to be a perfect replacement for the real deal.
Right.
We need to understand what assumptions are baked into these models, any biases, and use them alongside real-world data and, good old human expertise.
So it's not about replacing humans, it's about giving them better tools.
Exactly. I think the takeaway here is that we're in a new era of financial modeling, one where AI and machine learning are playing a bigger and bigger role. These technologies have the potential to totally change how we understand, interact with, and regulate markets. But it's on us to use them wisely, ethically, knowing both their power and their limits.
Couldn't have said it better myself. That's a great point to wrap things up on, I think. We've covered a lot of ground today.
We have.
From the basics of, what a limit order book even is, to these cutting-edge AI techniques for simulating them. We talked about the potential, the challenges, what this could all mean for the future of finance. Hopefully this has sparked some new ideas and insights for you listening out there.
Yeah, I hope so.
And if you want to learn more, there are tons of great resources online. You can always check the show notes, too, for links to the papers we talked about.
Definitely.
Thanks for joining us for this deep dive. Until next time, keep those minds curious and stay informed.